So, good morning, everyone. Today we have actually five problems in tutorial number 4. All the problems are related to finding the Lagrangian. Okay. So, for that, you have to first get the degrees of freedom, choose appropriate degrees of freedom, and finally, you write the potential, and that's done. You can write the Lagrangian after that, and then you apply the Lagrangian equation, and you will get the equation of motion. So, this is the scheme. So we will first write degrees of freedom. We will then write the potential. Then we will write Lagrangian. And then what is the Lagrangian equation, by the way?
dl by degree of freedom वाला
Hmm.
d by
velocity
dt
derivative.
dl by dq dot minus dl by dq
Yes, yes,
equal to 0.
is equal to this. So this is the formalism we will be applying to all the five problems. Okay. So first problem. See the right side figure for this figure. It consists of masses m1 and m2 suspended by inextensible string over a frictionless pulley. Find out the degrees of freedom, choose appropriate coordinate to evaluate the Lagrangian, and obtain the equation of motion. Okay. As you can see, by the way, how many dimensions are, how many particles are there? Number of particles?
Two.
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 So now you see what is the dimension of this problem like? It's a 1D problem or 2D problem?
1D problem.
1D.
Yeah, it's a 1D problem. So how many coordinates it will be requiring to?
One only.
So
One.
mainly for each particle you will require one coordinate, right? So total coordinates you will be requiring is 2. But there is a constraint. Can you tell me the constraint? What is the
L
Inextensible
equals
constraint?
to 1
string.
plus H2.
Yes.
Inextensible string.
The number of constraint is 1, which is actually this length is fixed. That means our x1 plus x2 is equal to fixed. Okay. So degrees of freedom will be total number of coordinates required minus this number of constraint, which will be equal to 2 minus 1 equal to 1. So the degrees of freedom is 1. Okay. So now you can choose either x1 or x2 for your generalized coordinate. Okay. So let us choose x1 for further processing. Now, after that, you have to write the potential energy. What is the potential energy? Because this m1 is x1 below the reference level, so you can write it equal to minus of mg
M1
x1. Oh,
x1
sorry, m1 minus m2
M2
g
G
x2.
L minus
We you can write here L minus x2, L minus x1, or you can finally substitute this x2 in the Lagrangian itself. Okay. So let me substitute in the Lagrangian later on. So Lagrangian will be equal to, you always write the kinetic energy. So kinetic energy will be half m1 x1 dot square plus half m2 x2 dot square minus of potential energy. Okay. Potential energy is, again it is having m1 gx1 minus m2 gx2. This is the general way you will be starting. Now you have to write this Lagrangian in terms of your generalized coordinate. And we have chosen that we will be using x1 as our generalized coordinate. You can also choose x2 for your generalized coordinate. It's up to you. Is it clear for you guys up to this part?
yes we
भैया यहाँ पे पोटेंशियल नेगेटिव क्यों होगा? हम लोग ने जो पोजीशन वेक्टर है वो भी नीचे की तरफ ही है ना, ग्रेविटी की वजह से.
Actually, change it to English version because this video also will be uploaded. Many will have a kind of correlation. I know it is convenient to ask in Hindi, but then sometimes, so just it's a request. It's not against Hindi, but just everybody has to catch the point. Just ask in English. If otherwise, if there's a difficulty in following, let's explain it. But until then, it can be just use the same version.
Okay, sir. Okay.
Thank you.
So now you see this this particle is actually x1 below our origin. Okay, we are choosing that our particle is x1 below. This length is x1. But when you write potential energy, what will be the potential energy for this will be mg length from the origin. And now see, this is actually below the origin. Na? So that's why we are writing it minus of mgx1, m1gx1. Is this clear to you? Or
Okay.
but this is very important. Okay, this many people will make will have this confusion. So please be clear. Okay, so you got it right, because we already know that this x1 is below this origin, and we are choosing like this only. That's why.
Okay, भैया.
Now, once we are now we will be converting this x1 and x2 with we will write x2 in terms of x1. So x1 dot will from here, if you take time derivative, x1 dot plus x2 dot is equal to 0. So here m1 x1 dot square plus half m2 x2 dot square plus m1 gx1 plus m2gl minus m2gx1. Is it fine?
Yes, Bhaiya.
Yeah. So next, this is, let us simplify this. It will be m1 plus m2 x1 dot square plus m1 minus m2 gx1 plus a constant m2gn. Okay. If a constant quantity is added to a Lagrangian, it will have no effect. Okay. Either you can write this or you can also omit this term or omit any constant which is associated with the Lagrangian. This you can feel when you write the equation of motion. If you are asked to write Lagrangian, either you can write full complete thing this, or you can simply write up to this part only. Okay. Next, when you write the equation of motion using this ddt of dq dot, you have to be very careful with the partial derivatives. You can take q and q dot are separate quantities. Okay. So dl by dq dot, you will see, no, you don't have to worry about q. While you do dl by dq, you don't have to worry about q dot. So let us find this ddt of dl by dq dot. You see, what are the terms having q dot? Q dot is now x dot. Okay, this one is having x1 dot, and no other term are having x1 dot. So we will be only taking the partial derivative of this term, which will give us half m1 plus m2, and the partial derivative of this term will give us 2x1 dot. Let me know if it is clear or not. Is this term clear to you? How we got
Yes,
this?
Bhaiya.
Anyone having any confusion? Please ask. Okay. Minus. No other term will be appearing because there is no other x1 dot term in these 2 and 3 term. Next, dl by dq, which is dl by dx now, x1. First term is not having x1, so it will contribute 0. Second term is having, so it will contribute. So plus m1 minus m2 g. Okay. Plus again third term is not having x1, so it will give 0. So that is why our final equation of motion will be this. Now this is total derivative. Okay, ddt of this. If suppose you have x1 also here, then you have to do the total derivative nicely. Now it's very simple. Only one term is there, so it will simply become m1 plus m2 x1 double dot will be equal to m1 minus m2 times of g. Okay. This is our equation of motion. Is it clear, everyone?
Yes, we
Yes, Bhaiya.
Okay. So now if you put m2 equal to 0, m1 x1 double dot will be minus plus g in this direction, same direction as the whatever we are checking. And if you put m1 equal to 0, if you put m1 equal to 0, then also we will be getting. Okay. Done. First problem is done. Simple. You just have to first find what are the coordinates available. Then is this a 1D problem, 2D problem, or 3D problem? Accordingly, number of coordinates required will be this. Then you find the number of constraints. Then to get the degree of freedom, you simply have to minus number of coordinates minus number of constraints. Last time also somebody asked me. Okay, we will get back to this one later on. I hope this is clear. Again, for the second problem. So again, we have to find degrees of freedom. Can you tell me how many particles are there?
One.
Only one particle.
1.
Now, is it a 1D problem or 2D problem?
2D.
2D problem.
2D problem.
So number of coordinates required will be
2.
2.
2 into 1, 2. Now tell me, is there any constraint?
Yes. Y equal
Y
to
equals to x square.
Yes. The number of constraints is equal to 1, which is y is equal to ax square. So degrees of freedom will be equal to total number of coordinates minus constraint equal to 1. Okay. Now which coordinate you will be choosing for generalized coordinate? It's up to you. You can either choose
X.
x or y, but because if you choose x, it will simply become x comma ax square. See, if you choose this as x, then one term will be x, one term will be ax square. But if you choose y, then one term will be y, but the other term will be little bit complicated. It will involve some square root. So we will be using x as generalized coordinate. Okay. Next, we have to write the Lagrangian. For that, before that, you will be writing potential energy. What will be the potential energy of this particle?
MGY.
And G square.
Mgy. Either you can substitute here, or you can substitute in the Lagrangian itself. Next, Lagrangian. What will be the Lagrangian? You always use like this. Okay, half m x dot square plus half m y dot square. This is the kinetic energy minus of potential energy. This part is clear. This is kinetic energy and this is potential energy. So we can simplify this half m. Now what is y dot square that we need to do? So y dot is equal to a into 2x into x dot. This is our y dot from this by taking total derivative, time derivative. So we got that our y dot square will be equal to 4 a square x dot square. So that's why we will be having 4 a square x dot square is taken out. So this will be our kinetic energy in terms of generalized coordinate minus u. U dot m g a x square a x. So this will be our Lagrangian. Is there any confusion so far? Is it clear to you guys?
Yes, we.
Now to write the Lagrangian equation, which is d dt of dly dx dot minus dly dx equal to 0. For that, first we will write dl by dx dot. You see which term is having x dot? Only this term. This term will contribute 0 here. So let us find dl by dx dot. Half m d partial derivative of this term with respect to x dot will be 2x dot, and this is simply constant, 4a square x square plus 0. This 0 is coming because there is no x dot in this term. Next, minus dl by dx. So dl by dx, this first term is only 1 into half m x dot square, which will give us 0. But this second term is containing x squared, so that's why it will give some non-zero value. So we will write this. Half m x dot square is already multiplied to this into 4a square into 2x. Okay, minus amg into 2x. amg into 2x. This is simple, right? But this is simple, you all can do it, but you have to be very patient and you should be very carefully do it. Don't simply ignore some term. Next, this 2 will get cancelled. This 2 will get cancelled. So if you now simplify it, now you see there is one term. Let me simplify it. ddt of m x dot plus 4a square x square m x dot minus 4 a square x dot square m x minus, so this will be plus 2mgax. Is this correct? Can somebody verify?
Yes, Bhaiya.
Yep.
This will be fine.
Now we have to take this total derivative, time derivative of this quantity. This step is very crucial. Okay? So now this is simple mx double dot, but this time here it is having x square as well as x dot. So you have to use UV rule. First it will be a 4a square 2x x dot. This is fine or not, you check. Okay, m x dot. First time is this plus 4a square x square m x double dot. We are doing the u into v product rule. Check this is fine or not. You can understand this or not.
Yes.
Good.
Yes.
4 m a square x x dot square plus 2 mg a into x. Okay. Now this is 8 a square m x x dot square. So if you simplify this, it will become m x double dot plus 4 m a square x x dot square plus 4 a square x square m x double dot minus 2 mg ex. Okay, so this is the final answer.
Bhaiya, I
Please
had
check.
one small doubt.
Yeah, ask me.
Since the whole equation is zero and we are only considering one particle, can we cancel the mass just for the sake of simplification?
Yes. So finally, we will be cancelling
Okay.
this mass because it is independent of mass. So it will be
Yes.
having m e square x. Sorry, 4a square 4a square x square. Yeah, so 4a square x square. Yeah, plus 4m a square x x dot square minus 2m to cut it here 2g a into x equal to 0. So this will be our final answer.
I think the sign for +2m, it should be +2. The last but one will have plus sign.
Oh yes, yes. So thank you, Satya. So this will be having this. Okay, anyone having any doubt what we did? You check number of particles, you find if it is 2D problem, 1D problem or 3D problem, then number of coordinates required, number of constraints, then to find degrees of freedom, total number of coordinates minus constraint, which will be giving you 1 for this problem. Then you choose proper generalized coordinate, then you write the potential energy, simple mgy, then Lagrangian, kinetic energy minus potential energy. Okay. Also very careful about this sign, don't write plus, then write this Lagrangian equation, then slowly you do this partial derivative. Carefully you do, and you will get the final equation. Next, the third problem. Here a mass is there, so it is okay suspended from an inextensible string of length L as shown in this figure. We have to find degrees of freedom and Lagrange, same thing. Okay. So this problem, if you see, this problem is actually pivoted. This pendulum is fixed here and it can oscillate about theta, and plus it can also rotate. It's like this. This problem is a combination of two problems. First thing is it can oscillate like this. Second is this angle is theta given to us, and also it can rotate in phi plane. Okay, can you guys identify this problem is a combination of these two? So the particle can oscillate like this, plus it can also rotate like this. Are you guys with me?
Yes.
Okay.
Yes,
So
भैया.
let us. So how many particles are there here? Number of particles?
1.
1. Is this a 3D problem or 2D problem or 1D?
3D.
3D. So what will be the number of coordinates required to identify this particle?
3 r theta phi
3.
coordinate into 1.
Next, how many constraints are there? Number of constraints?
1. Length of string is constant.
Length of the string is constant. So what will be the degrees of freedom?
2.
Total number of coordinates minus this constraint. So which will be equal to 3 minus 1. So total 2. So which generalized coordinate you will be using?
R theta phi spherical coordinate system.
Yeah.
Theta and phi.
Theta and phi. जो दिया हुआ है figure में, whatever is given in this figure, so we will be using theta and phi as generalized coordinate. So once you get this, you have to write again the potential energy. Now this is critical. Okay, what will be the potential energy? We know this will be mgz. Okay, are you guys with me?
Yes.
So simply, so you now put what is z in spherical coordinate system. Z is equal to, anybody can tell me?
L
cos theta.
L cos theta. So that's why it will become simply L cos theta. You can substitute here also or in the Lagrangian itself. So this is RE. Now we have to write the Lagrangian. For that, we know it will be equal to x dot square, y dot square, z dot square minus of u. Now you have two way to proceed. Either you write x equal to this L sin theta cos phi, L sin theta tan phi. You find x dot, you find y dot, you find z dot, and take the square. and substitute here. Or you already know that this thing actually comes from the velocity, right? Velocity of the particle. And if you somehow know the velocity of this particle in your new coordinate system, like this theta and phi are part of your spherical coordinate system, right? If you can somehow write this velocity in spherical coordinate system, then you can simply write the kinetic energy also. So let us write the velocity in spherical coordinate system. What will be this? Anybody
R dot
remember?
R dot
Yes,
theta cap R theta dot
r
theta
dot
cap
r cap plus r theta dot theta cap. Yes,
R sin theta phi dot phi cap.
r sin theta phi dot phi cap. So because length is constant, this term will be 0. So this will simply become L theta dot theta cap plus L sin theta phi dot phi cap. Now to get the kinetic energy, we need V square. So which will be equal to V dot V. That means this square plus this square. So our kinetic energy will become half m this part square L square theta dot square plus L square sin square theta phi dot square. Okay, minus of m g L cos theta. This thing, this part you can also get by substituting this. You please try this in your home. How to get z dot, x dot and y dot from this. Then you take square, you will get this. Okay. If you are not able to write directly this quantity, you have to always go through this step. If any problem, you are not able to write if suppose your generalized coordinate is a mixture of two different coordinate systems, then you cannot write it simply like this. Are you guys with me?
Yes.
Yes, yes.
So and if you are sure that yes, my generalized coordinates are part of my cylindrical system, my spherical coordinate system, then you can simply write like this. Now, once you get this Lagrangian, it's very simple. So we have two generalized coordinate here, theta and phi. So first we will be doing with respect to theta, then we will be writing with respect to phi. So we will get two equations. So let us write the two equations. d dt of dl by d theta dot. Okay. So half m. Theta dot is only here, nothing else. So it will simply become L square to theta dot. This part is done. Minus dl by d theta. Theta is here and here at two places. So half m L square dd theta of theta sin square theta, which will give us 2 sin theta cos theta. Okay, this part is clear. This is very simple. dd theta of sin square theta, which will give us 2 sin theta cos theta, minus mgl dd theta of cos theta will give us minus sin theta. So this will give us 0. The first equation is simple. We got it. ml square theta double dot minus ml square sin theta cos theta phi dot square plus minus mgl sin theta equal to 0. Okay, then this m you can cancel. So this is the final equation you will be getting. Theta double dot will be equal to sin theta cos theta theta dot square plus g sin theta by l. Okay, are you guys with me?
Yes.
Yes, yes, yes.
Okay. So next to write the equation in term for the phi generalized coordinate. So this will be d dt of only phi dot is in this term. So half m L square sin square theta square sin square theta, and theta squared का partial derivative will give us 2 phi dot. Okay? Minus, is there any phi term? First term is not having phi, second term is not having phi, because we have to do partial, because we have to do dl by d phi. Okay, so if any term is having phi, no, so that's why this term will give us 0. Okay, so this part you will get in next classes, like if Lagrangian is not having a coordinate dependency, then this is called cyclic coordinate. This part you will get in next classes. Now if you see, if a coordinate is cyclic, then corresponding to its momentum, you will get all those things. So this will be becoming m l square sin square theta phi dot is equal to constant. Can anybody identify what is this term in our problem?
Velocity in phi direction. No.
Omega of angular pendulum.
So it's like m r square omega, right?
Yes.
M r square omega is angular momentum, right?
Yeah.
Yeah.
So this is nothing but the angular L, and R is L sin theta. L sin theta, if this is L, this is theta, then L sin theta will be this distance, right? Are you guys with me?
Yes.
Yes. Yes.
So yes. So angular momentum about this axis. So this is angular momentum about z axis is constant. And why it is so? Because there is no torque corresponding to this, right? Gravity is pointing like this. So that's why.
Bhaiya, here we are getting zero. So does this mean that it is zero, angular momentum zero is, or it signifies something else?
No, no, no. The angular momentum is, from here we got that angular momentum is constant, not zero.
Okay.
It will depend on the initial angular momentum. If your initial angular momentum is something, then it will remain like this. It's like if you are giving some initial velocity to this, initial velocity in phi direction, then it will remain like this.
The more physical explanation we will be discussing in the next class. So what exactly it means, how we derive, like as he said, there is a concept called cyclic coordinate. We will discuss that in the coming up classes. Then you will understand more with the examples. Right now you say that when derivative of, a function with respect to time is zero means the function is typically a constant. Correct? That's a simple definition.
Yeah.
Okay, so.
So now if you see, if you give no speed in this direction, phi direction, this term will become zero, right? If initially your phi, suppose your phi is not changing, that means phi dot will become zero. That means your equation will become theta double dot will become g sin theta by L, right? Is this fine?
Yes.
Yes.
So that means it will do the for very small angle. Oh, by the way, yeah, for very big angle it will become, because our theta is now like this direction from here. So if this angle is very small, if this angle is very small, then sin theta will, we can write it as theta. Don't say theta is very small. Okay, theta is very small मतलब तो ये तो इधर आ जाएगा. This pendulum will be here, so it will not do a simple harmonic oscillation. But if this angle is small, then your pendulum will oscillate like this. Okay, are you guys with me?
Yeah.
Yes.
Next, question number 4. Question number 4 is shown in this figure. This string, this length can also change, and this theta can also change. Okay, now same thing, number of particles. 1. What problem? कौन सी dimension का है?
2D.
2D.
Number of coordinates?
2.
2.
2. Number of constraints?
Non 0.
0.
Degrees of freedom?
2.
2.
बहुत अच्छा. I hope everybody can find degrees of freedom by now. Next, what is the generalized coordinate you will be using? Already given theta and x, so we will be using theta and x. Next, you have to write the potential energy. What will be the potential energy?
mgx cos theta.
Yes, minus of mg l plus x
Cos theta.
cos theta.
Plus
You
half
have to
x.
write complete. Sorry,
No.
plus half kx square. K into extension square. Extension is x. Okay, this is fine. Once you are done this, then L. L, how to write L? Half m. Now see, this is a combination. This one also you can write simply like this. This is these coordinates x and theta, x square plus y dot square minus u. Now your y is equal to this coordinate. Suppose this is x. Wait, something not right. This is L plus x, which will be your r in spherical coordinate system. Yeah, you can simply write like this: half m r dot square, which is r x dot square, plus I'm writing like this: r dot square plus r square theta dot square. Phi तो है ही नहीं, so r is r L plus x whole square and theta dot is theta dot square. Can you write like this? Are you guys with me?
So yeah, I have a small confusion.
Hmm.
In polar coordinates, the angle with x-axis is theta, right? But here it is with y-axis. Then how can we take?
In polar coordinate,
Theta is the angle
Mhm.
made by the position vector with x direction, no?
hmm.
But it is here it is with the y direction. So how can we write polar coordinate?
Oh.
That's a good question.
Mhm.
It doesn't matter.
I
I
mean, I
think
have done in the same way, but I have taken 90 minus theta. Then I have done.
Sir, I just took the vertical as the x-axis. Then we can write potential energy also as x cos theta, and it just works out.
So this one you
no,
are
it's
writing
only
as,
mere representation. There is no
yeah,
confusion
yeah,
in that.
yeah.
Oh, okay, sir.
Okay, now if you rotate this by 90 degree, it will become like this.
No, but the doubt was genuine.
Yes, yes. Okay. So next, you will be simply writing minus of mg L plus x cos theta plus half k x square. So once you have this Lagrangian, rest of the part is simple again, same thing. ddt of dl by, let us write for x, dl by dx dot, it will give us m x dot. This term will give nothing, so done. This part is done. Minus. So let us simplify this Lagrangian as well. Minus, minus. So it will become plus. And minus and plus, it will become minus here. dl by dx. This term is not having x, but this term is having x. So it will become m l plus x theta dot square. I think I have made some mistake or what? No, it's fine. Plus. Then plus m g cos theta minus k x is equal to 0. So the first equation is done. Now you simplify this, ddt of mx dot will become mx double dot. Okay, that's it. Your first equation is done. For the second equation, what we will do with respect to theta. ddt of, are you guys with me?
Yes, Bhaiya.
So this will become half. Theta dot is there only in this term. So it will become m l plus x whole square theta dot. This term is done. Minus. Is there any term containing theta? Yes, this term is containing theta. So dl by d theta, which will give us mgl plus x cos theta का derivative will give us sin theta minus sin theta equal to 0. So finally, now this term is also having x and theta, so you have to use UV product rule. So it will become m l plus x whole square theta double dot minus plus 2m l plus x dot theta dot. This term you see, okay, this term is not, don't write simply m l plus x whole square theta double dot. You don't omit this term. This term will also come. Plus mg l plus x sin theta equal to 0. So these are the two equations you will be having. Okay, are you guys with me?
Yes.
Yes.
Now same way, if you fix this length, like if you fix your x to be equal to 0, your pendulum, it will become a simple pendulum which will oscillate about theta. So put your x to be 0. So this term, this will become basically L square theta double dot plus, you don't have any x, so x dot be bhuli jao. So G L sin theta is equal to 0. So which will basically give us minus of G theta by L for very small angle. So this is our simple pendulum equation, right? For x equal to 0. If, let me write for x, yeah, for x equal to 0. Like if you do not have any play in this spring, if your spring is replaced by a string, then you will get this equation. Then if you put your theta to be constant, you play only in this direction, only along a x, so then your theta variables can be omitted, so which will become mx double dot. This term will not remain, this term will not, or this term will be there. So let us put this along here. It will oscillate like this, so it will become mg plus kx equal to 0. This is the equation of the spring. ठीक है?
Yeah, why have we neglected cos theta term?
मैंने फाइनली ना स्प्रिंग को ऐसा बना दिया. I am basically simplifying this case बना दिया. I am making this case. If our spring is like this,
Then mg will be there.
mg will be there. Yes. Sorry. Yes, mg will be there. So it will become minus mg equal to 0. This thing will be there. Yes, thank you. इसमें mg फोर्स नीचे लगेगा, kx ऊपर लगेगा. ठीक है?
Yes, भैया.
Okay.
Yes.
So the next problem, final problem. So this is, how many particles are there?
2.
2.
2 particles. Number of particles 2. 2D problem, 3D problem,
3D.
3D problem. Yes. Now, so total number of coordinates required.
2.
3D
Same.
2
problem
for
we are saying. So
2 for
2
A
into
and
3.
1 for B.
Yeah, we will write the constraints also. So 6 coordinates. If you are considering a pure 3D problem with 2 particles, it will have 6 coordinates. Now you see that this particle A cannot have z direction, right? It cannot move in z direction. The
Yes.
particle A's z coordinate is fixed. And for particle B, it cannot have play in x and y direction. So particle B's x position is fixed and y position is fixed. Okay, 3 we already get. And
one.
also this length of the string is constant. Length of string is constant. Okay, suppose this is R, this is Z, that means R plus Z is constant. So how many constraints you have got so far?
4.
4. 1, 2, 3, 4. Number of constraints equal to 4. So finally, what will be the degrees of freedom?
2.
2.
6 minus 4, 2. Okay. So now, which two coordinates you will be choosing?
I have taken
Yeah.
distance of B from plane and angle theta of A.
Yeah. So we can have one angle theta, or so you
And
have two
Z.
options. You can play theta z, or you can have theta and r.
Theta. Oh, yes. That.
So what is the benefit of choosing theta and r?
We
You
can
can
take
simply,
plane
you can
polar.
directly write
Or
it. Kinetic energy part, it will be very simple. But both are same, okay? Both
Both are
identical.
similar only.
So next, let us write the potential energy. Suppose we are choosing this plane is having potential equal to 0. So this body will be z distance below, so it will become mgz. So Lagrangian half. By the way, this particle is having mass m and this one is having small m. So our kinetic energy will be half capital M r dot square plus r square theta dot square plus half small m z dot square minus potential energy, which will give us mgz. Is this Lagrangian fine? This is coming from particle A, this is coming from particle B, and this is our potential energy. Are you guys with me?
yes.
Okay. Now we will simply replace this z. We want to use this. So you replace this half capital M r dot square plus r square theta dot square plus half m r dot square, because r dot plus z dot is equal to 0, plus mg L minus mg r. We are replacing this z with L minus r. Because this term is an offset term in the Lagrangian, you can either neglect it or you can carry. We can take this for your calculation. The next part is simple, okay? You have to choose with respect to r and with respect to theta. So let us do this with respect to r. This one is having r dot, so half capital M r dot into 2. First term is done. This term is not having r dot, but this term is having r dot. This will also give n r dot. No other r dot term. Done. Minus dl by dr. First term is not having, but here it is having m r theta dot square. Again minus mg is equal to 0. So the final equation will be n plus m r double dot minus m r theta dot square plus mg equal to 0. First equation is done. Then second equation. Second equation, this one with respect to r, this one we will be writing with respect to theta. Again, same thing, ddt of m r square theta dot, m r square theta dot. Any other term? No. Minus dl by d theta. No term is having theta dependency, so which will give us m r square theta dot is equal to constant. By the way, what is the significance of this term?
Same angular
Momentum is
Same
constant.
thing, yes. Angular momentum of this particle is constant. About the z-axis is constant. Okay. So same way, if you are given some initial angular momentum, you can simplify this equation and you can get this. You can solve these two equations. So overall, all our problems are similar, of difficulty level different. But the thing is, what in all the problems, you have to first get the degrees of freedom, then write the potential energy in terms of your generalized coordinate, like the Lagrangian, and you have to remember the Lagrangian equation in order to get your motion equation of motion. That's it. Any doubt?
Sir, can you show the third problem once? I just wanted to check.
Yeah.
Okay, sir.
Okay, good. So anyone other than any doubt? Then I will assume no doubt. By the way, in last problem, last tutorial, there was one question, how to find this question. Two charges were there, then two charges were fixed by a rod like of length twice L. You remember this question? Somebody asked me how to write the degrees of freedom or something.
Yeah. I
You understood this question, right? You understood the degrees of freedom?
Yes,
Same way, okay? These two particles are fixed. We will ignore them because these are two particles. Total number of particles is
two.
2. This is a 3D problem, right?
Yeah.
So 3D problem. So total 6 coordinates will be required. Now the number of constraints. This particle is not allowed to move in
In Z direction.
Z direction. Both the particles are not allowed to move in Z direction. So two constraints, 6
Yes.
minus 2, 4 remaining. This length is constant,
Yes.
minus 1 again. And also the center of mass of this system is not allowed to move in Y direction.
Y direction.
That's why one more constraint. Sorry?
Yes.
Okay. So total,
Yes. No.
finally we got that degrees of freedom was 2. Also you can think like this. Suppose this is a rod.
So, we have to minus 1 again.
कौन से क्या?
I mean, I want to say when sir taught us, there were 3 degrees of rotation
Okay,
about
if you
x-axis, y-axis, and z-axis.
yeah, I will say like this. If you are having a rod, this rod is in 3D, so this can have 3 translational motion. So for that you will get 3 coordinates. Also it can rotate in 3 direction, right? So total 6 coordinates will be required if you want to put this rod, track this rod's movement. Now this rod is allowed to move only in this direction. So -2 translation and motion is gone. These are the constraint. Now this rod can also rotate only about this z-axis, not about x-axis and not about y-axis. So -2 will be gone again. The total degrees of freedom will be 2. You can think like two ways, this way or this way.
I thought previously you said something about length is constant.
Yes, because I was saying I was considering only two particles. In this case, I was saying that we can think like we are having two particles. That's why. First constraint was it cannot move in z direction. That's why I made this -2 for this two. This one, I was saying that this length is constant. And this one, because the center of mass of this system cannot move in the y direction.
So I think there will be five constraints.
Why do you think so?
Because length is constant, that is one,
Hmm.
and it cannot translate in z direction and
Hmm.
y direction, center of
Hmm.
mass,
Hmm.
and it cannot rotate about x-axis
Hmm.
and z-axis. No,
Now,
about y-axis. Sorry.
okay, you have to choose your convention first, right? Are you choosing this as rod or you are choosing this two particles as two particles?
Okay.
See, if you choose like this, if this is a rod, then it will have 3 translational degrees of freedom and 3 rotation degrees of freedom. And by default, as this is a rod, length is constant. It is already, you already put the
Okay,
constraint
and
that this is a rod.
okay, thank you.
Okay then. So if nobody is having any doubt, we can leave and all the best for the quiz.